welcome to the BS and Beer Show. BS stands for Building Science. Obviously, I'm Emily Mottram, and it's no longer dry January, so I am having a Bellflower Brewing IPA. This one is called The Sun, I think. So nice IPA that one of my contractors gave me for Christmas that I couldn't drink for a month. So tonight we're going to talk about verification, which is one of my favorite subjects to talk about. This year, we're trying something new. We're going to do 60-minute long shows instead of 90 minutes. We're keeping it informal. So we don't have a script. We're not planning on sharing stuff. We're just a bunch of people talking about some things that the four of us all really care about. So post your comments and stuff in the chat box. BS and Beer is an independent grassroots movement to share building science knowledge through local meetup groups and this, our Zoom show. I don't know if anybody's tuning in from out in Las Vegas, but Ben and Travis have been out at the International Builder Show all week. So hopefully you guys got a chance to catch up with them. And if you're a pretty good house enthusiast, Chris is wandering around there somewhere too. So get him to sign your books that are available in the store out at IBS. But we really encourage people to start their own local groups. BS and Beer was started from our local group, pandemic, and now we're doing this online for everybody who doesn't have a group yet. Check out our December 2022 show on how to start a group if you're interested in doing so. I think at this point, everyone's pretty familiar with Zoom, but if you're not, the chat box icons on the bottom of the screen, post your questions and comments there. Mike or I will be monitoring the chat box. I see a lot of you are familiar with the show, so introduce yourself, tell us where you're from. Please pick everyone in the chat box. May also say all hosts and attendees, depending on which version of Zoom you have. Otherwise, only the host can see your comments. So make sure that you pick everyone. And for whatever reason, Zoom likes to automatically go back to only hosts. So check it every time you post. To get announcements about upcoming shows, join our mailing list over at the bsandbeershow.com and check out Kylie's monthly BS and Beer post on Green Building Advisor. Once you're registered through Find Home Building, you'll get automatic updates. That only tells you that there's a show coming up. It's going to be the first Thursday of every month this year. If you want to know what we're talking about, you got to get on the mailing list. Video recording for tonight's show will be up on the BS and Beer Show's website on YouTube and also on Green Building Advisor. And last, thank you to our media partners and Green Building Advisor and Find Home Building magazine. I've had the pleasure of knowing both of our two guests tonight, but I'm going to kick it over to Mike to introduce them.
Thanks, Emily. Mike Maines. Tonight I am drinking a Spindrift Lemon. I did not go dry in January, so we'll make up for it tonight anyway. I just have one quick announcement. Next week is the Passive House Maine annual forum on Thursday night. Some of us will be doing a book, a Pretty Good House book signing. It was going to be a panel discussion. It sounds like it's that plan has changed. So I don't know. Anyway, next week I'll put a link in the chat if you're interested in the Passive House Maine forum. It's always a good show. Our guest tonight, Kramer Silkworth, is principal at Bowcraft Engineering, which he founded in 2012 to provide state-of-the-art mechanical system design for residential projects. Kramer studied mechanical engineering at Rensselaer and began his career as an energy efficiency consultant in Stuttgart, Germany, and then in New York City. He has also worked as a Passive House trainer, and somewhat coincidentally, he trained both Emily and me to be Passive House consultants. And in his spare time, Kramer enjoys turning wood on a lathe. You can learn more at bowcraft.com. That's BAUKRAFT.com. Kramer, what are you drinking tonight? And did I miss anything important?
Right. So tonight I'm drinking some red wine that may have come from a box, whatever. It's Thursday night, whatever. No, good intro. Thanks, Mike. Great to be here.
Thanks. And Mike Brown is the co-founder of Advanced Building Analysis and Energy Star partner, helping builders of new single-family and multifamily homes to cost-effectively meet the challenges of higher energy efficiency standards. They use computer modeling to assess thermal performance from plans, on-site diagnostic testing, and share best practices with builders to optimize thermal performance. Mike has a degree in material science and engineering from Brown University and formerly was a professional woodworker. You can learn more at advancedbuildinganalysis.com. That one's nice and easy. I don't need to spell it. I don't need to spell the words, I don't think. And just coincidentally, yeah, so three of us are woodworker nerds. And it's funny how much overlap there is, I found, between I found woodworkers and high performance building just seem to go together for no good reason other than I think we really like details.
Oh, there's lots of good reasons.
Yeah.
So, yeah, after college, I decided engineering looked like it wasn't hands-on enough. I went into engineering of all my options because I thought it was the most hands-on of the options, and it still wasn't very hands-on, particularly in the early 90s. Things were very theoretical. So I went straight out and became a wooden boat builder for 8 years. Ended up working at the oldest continuously operated boat shop in the country, where I live still today in Amesbury, Mass. That's the Lowell's Boat Shop. Did that for a while, and then went into architectural woodworking, where I programmed CNC machines for a high-end architectural woodworking shop in Newburyport called Mark Ritchie. So I've seen both ends of this spectrum on the traditional and the most modern, working with $200,000 routers that are fully programmable. And that all that background was really wonderful for what I do now, particularly running the CNC department there. It was a bottleneck potentially for everything going through that factory between the engineers and the architects and the project managers on one side and the job captains and the crew on the floor on the other side. Everything had to get through our department, and it taught me a lot about dealing with a lot of different people and helping prioritize things. And I'm still in that kind of role, potentially a bottleneck.
Well,
So-
awesome.
Oh yeah, so I think the big question tonight, most people know, but for anybody who doesn't know what verification means, would one of you be willing to take a stab at explaining what does verification mean to you? And well, I guess, yeah, well, what does it mean to you and why is it important? What is verification when it comes to building? Why do we need to do it? What would you say, Michael?
Well, man, there's so much on that topic, but I'm thrilled that we're talking to the fine home building audience here. I think you really get trying to do things the right way. I remember reading fine woodworking and fine home building and trying to learn how to do things the right way myself many years ago. And so it's all about that in a very fast changing landscape of our understanding of how buildings work and all the materials available, all the systems available. And I find our job, the job of a verifier, it's a lot more than just a verifier, first off, but you have to be aware of so many different things. And you're always trying to figure out, all right, what's going on here? Every day is different on a different job site, talking to different people, approaching the project with different goals and different materials. And you'll learn a lot. And I'm always learning every single day. That's a very rewarding part of it. But why you need verification? Well, because things don't always go right. And these programs that want to help change the marketplace, it's all about market transformation. We're trying to show people how to do things in a better way, in a lot of different ways, whether it's durability or health or energy efficiency, whether it's operational carbon or embodied carbon. All of these things get wrapped into the discussions we have every day.
All right, excellent. And Kramer, is verification part of your daily practice, or is it a weekly thing? How does verification work into your end of things?
So I do a bit of a mix of things. It's primarily mechanical design. I'm a mechanical engineer by training, although sometimes I do regret that and wish I'd taken a path maybe more like Mike's here. But I do a lot of my own blower door testing, duct leakage testing, ERV balancing, makeup air system balancing. Partially because I don't like sitting in front of a computer for 40 plus hours a week, but also because I want to know what parts of my designs are working and what aren't. I don't care how good your plan sets are nothing ever works perfectly in the real world.
What,
Like,
really?
good. Yeah. Weird. Yeah. Weird. Like the best plans in the world don't mean shit if you're not out there in the field looking at it. How is it being built? Can things actually fit where we thought they would? And does this stuff actually work the way we thought it would? And do people know how to take care of it in the long run also? If you walk away from a job site thinking, all right, everything here is perfect and will be for the rest of this building's life, you're not doing it right. There's always something, at least a little bit amiss with how things get actually constructed in the real world. Sometimes
Yep.
quite amiss. And we need to be checking these things, and it's not that hard to do. Making a cameo. I fed you so you wouldn't do this. Come on. Yeah, it could be little stuff, it could be big stuff, but we need to complete the design loop here and verify and learn from what works, and mostly learn from what doesn't work to be applying on the next ones, because we don't have buildings completely figured out. Like, we understand the theory pretty well in most areas, but I can't think of anything else that humanity has created that is more diverse and complicated than our own buildings. And we've been at it for like 6,000 years, and we're still finding ways to screw it up. So you got to check what you've actually built. Is it actually working? Chances are there's at least something that needs to be tweaked on every single building out there.
Yeah. And our particular area of expertise is, measuring airflow and looking at things with thermal cameras. We bring to the table as verifiers tools which help anyone who's interested figure out much better than they could on their own how their building is operating. So when we look at a building under pressure, we're taking something like a 25 or 30 mile an hour wind and pulling it from every single direction, top and down, bottom up, in every direction. And you just don't get that chance otherwise to have this exaggerated air leakage. And then putting that together with a thermal camera, you just learn so much. I'm learning every day. And I'm just trying to share that with everybody. But that's we're always working towards some sort of holistic goal. But the tools there's two things we bring which are really important: the special tools, but also that holistic approach with the energy modeling, which means we don't get carried away with one thing to the detriment of another. That your investment should be balanced in all these complicated things in a way that with things which are really hard to compare, apples and oranges. A mechanical system and the amount of insulation you put in your wall. Our energy model helps people sort that out. What's the smart investment, and help make sure we didn't miss something. I mean, most importantly, I get to projects where they've done 90% of the things brilliantly, but then there's like some big gaping problems that we can help them identify before it's too late.
Yeah,
it gets buried and completed with the building.
They added a sauna. They added a giant range hood. They added a fireplace.
Yeah.
Don't you love that? Kramer said something that I one of my favorite things about verification, which is like, okay, we modeled it, we did the best we could for plans, and now you guys went out and you verified it. You're like, okay, it's operating the way we expected it to, but like, we're the professionals, we know how to operate it. Then one of my favorite parts about verification is client education. Like, do you know how to operate it when I leave? And like, part of verification too is helping clients to understand, like, you have to change the filters, and like, no, you can't put a HEPA filter in this mechanical system that we didn't design for a HEPA filter. Or you were talking about ductwork, and that was an aha moment. Mike is the parent company for my HERS Rater certification. And one of our other raters, Bill, was doing a final inspection for me because he's got even cooler equipment than I do. So we were out testing out a house, and the builder said to me afterwards, he said, we did all this stuff and I didn't realize how much the ductwork was going to make a difference. Like, he was so good about the air barriers and all the stuff that he did. And he's like, well, dang, like I needed to do a better job on sealing the ductwork. And like, that was his aha moment for that project. I mean, it still blew under one. It was still a great project, even with more ductwork than we were anticipating. But, those, like, what I love about verification is going out in the field and then them having that moment that says, oh yeah, like, okay, this is what I need to pay attention to next time. Like, what was the thing I didn't know? What was the unexpected? And I totally agree with Mike. It's some new problem on every project. Like, you show up and you're like, what am I going to learn today?
And I love problem solving to a fault, from other people's perspective. When I worked in that architectural woodworking shop, if things were running smoothly, I was kind of bored. And there was lots of ways to screw up. So we did it a lot. And it was always a new way. And it was always like fun to try to figure out what went wrong. But I learned at some point, all right, Brown, you just can't start grinning every time things go wrong when everyone else is pissed off. But you have to kind of love the problem solving, and there's just so much of it to do.
Yeah. I'm going to play dumb or play dumber than I am for a second. Is it unusual for an architect like Emily and an engineer like Kramer to own their own blower doors and to use them and to know how to use them?
Extremely unusual. Yeah, absolutely.
Is it something that should be more common? Do you think is it best left to an independent professional like you, Mike, or is it?
Great question. So when people want to become, so we haven't even said the word HERS rater yet, and usually when I have a big audience, I say, who in the room knows what a HERS rater is?
Yeah. What is a HERS rater?
Yeah, I mean, I don't know. You can't really do a show of hands here, but at this point in time, I've been doing it for 15 years. And I kind of expect, being in Massachusetts too, that most people know what this is. In fact, 87% of new construction in 2021 was HERS rated, residential construction. So I'm super proud of that. The next state back was maybe Chicago or something like that. Chicago, Illinois, the state. But they were like 50%. There's a handful of other states at 50%, and in Massachusetts we're at 87. So we're doing a ton of this work, but it's amazing how people still don't know what it is, where it came from, what it stands for. Home Energy Rating System is what HERS stands for. It was developed by the mortgage industry as a way to pay for cost-effective energy efficiency. In other words, when you had energy savings, because something you did to improve your building, the mortgage company could look at that as extra income that you could use for borrowing against, right? They can lend you more money. So that's great. We want to get better insulation. All of a sudden, it pays for itself. Great. We can borrow money just for that exclusive thing, separate and above everything else you're borrowing for. So that was the origin of HERS rating. And it was in the early 90s when financing was incredibly easy to get, and nobody really did it because you could get all the money you wanted without going through that. But the organization that did latch on to HERS rating, because it was a nicely developed system, was Energy Star, the Energy Star Homes program. So as an overall program, Energy Star is always trying to recognize products that are at least 15% better than the market average, and work on industries where there is a good span of performance, so that we can, if everything is about the same, there's no Energy Star product. But if you have a good span of things, they'll have an Energy Star product. So buildings are a great one. And they worked out this system for Energy Star homes, and then incentive programs started using HERS rating and Energy Star homes as a way to qualify people for incentives. The big incentive program that first came out was from utility programs, who had to, by agreement with the state in Massachusetts, the utilities had to pay for all cost-effective energy efficiency improvements. So if you could demonstrate that you were doing something cost-effective in improving energy efficiency, the utilities had to incentivize it. Still have to. So that's where these programs come from. We have to be very concrete in demonstrating the energy savings. These are called asset ratings because they describe the way the building is built, not how the particular people end up living in it. So we're evaluating it and anticipating the average Americans living in that building based upon our software's recognition of residential patterns. And we can give the builder credit regardless of who ends up living there and leaving all the windows open. So I started rambling because I can do that.
Well, it's
Reel
good.
me in sometimes.
Yeah. No, well, let's get, or no, that's, I think,
Yeah.
I think that's a good overview. Yeah. Yeah. Anything to add to that, Kramer or Emily? Is hers something you use or see in daily practice?
It's like I do a handful of FIAS certified work, so they've rolled in their verification process, the FIAS rater. I think everyone has to be a HERS rater to start,
Mhm.
and of course all the Energy Star stuff, which I think was a great move by FIAS, because that's where things were lacking. Otherwise, in passive house building, it's like you had to balance your ERV, and that was about it. But no, we need to know, is the AC and heat working properly? How's the hot water distribution? All these things matter. But that's been my closest contact with most HERS rating. I think some Long Island counties are requiring it now also. And it's being rolled more into code as a compliance option, I think, in our stretch code that we have now. But that's been my extent of contact with the HERS approach.
Okay.
I
Yeah.
came into this whole stuff through Passive House, so I'm kind of like,
Right. And I came to Passive House through HERS. So the HERS is the core of our business. And from that, all these other programs have been built. Energy Star was built on HERS. These utility incentive programs are built on HERS. 45L tax credits are built upon HERS. The DOE Zero Energy Ready Homes program, Passive House rating, the National Green Building Standard, everything has the HERS method and at the core. And we still haven't really talked about what that entire method is. It starts with energy modeling from plans and as the first concrete big step where we give feedback on how the plans look like they'll do overall. And we're always looking for ways to do better. We're going to try to identify and prioritize the things that you could do better. Right. And too often, I think people focus on relatively trivial things while missing out on big opportunities. So I think one of the HERS raters' major tasks is to reorient people to the most important decisions. The decisions will have the most impact and the most energy savings, making sure that everything is going to work together holistically. So that's the first phase. And in Massachusetts now, you need to do that to pull a building permit in most of the state. So after that, in the middle of construction, we're looking at all the insulation before it gets covered up by sheetrock. This is our chance to evaluate how well the insulation was installed, and at the same time, look at how the thermal envelope is coming together, anticipating our final inspection when all the testing happens. And sometimes you can do testing at the midpoint. Builders don't always plan for it. We encourage them to do it. It's not required. Doesn't always happen. But you can sort of head off problems that might happen at the final if you do the testing, blower door testing or duct leakage testing at a rough. We can even do some ventilation testing sometimes. This morning, I was pointing out some ductwork for an ERV that was just horribly convoluted and bent back on itself. I told them it's going to be, and this is a rough inspection, so the sheetrock's not on yet. And I said, this is going to be noisy. You don't want this, do you? And the architect who was there was trying to say, no, it's fine. It's a short run. It's not going to be a problem. But the builder who was with us too was actually able to turn it on, right? And this is unusual at that stage of construction, but they already had the HVAC working and the ventilation working before sheetrock, and they turned it on. And indeed, it was quite noisy because of the tortured path of the airflow. And so I'm trying to, that's just one of the things we're looking at that rough inspection. Does the ventilation system look like it's going to work okay? Are the hot water pipes insulated where the code says they should be insulated, but everyone else seems to be ignorant of that. Then finally, so at that final inspection, we test the duct leakage, we test the infiltration, and very, very, very importantly, we test the ventilation. Right, we've tightened up these buildings. We got to make sure the ventilation system works properly, and it's amazing how often they don't work properly. Even so we're always trying to steer people towards a system that will work properly, from the design through the installation through the commissioning. But if there's one thing that holds up a passive house project in particular, but all projects in general, when everything else is complete, it's a ventilation system that's not hitting all its marks.
Yeah. And I would say, as a HERS rater, obviously I use HERS certification and inspection stuff just more often, although I did do passive house training and everything else too. Learned a lot about mechanicals from Kramer. And what I'd like to say is that unfortunately, a lot of projects don't have a residential mechanical engineer to help them through, right? So with verification on a project, depending on where you're at, you may have somebody else. And like, for us, there was a lot of pushback because, ERVs weren't tested out, right? So you just talked about ventilation at the end of a project. And like the only people who were doing it was Zender across the board. They always tested out their commissioned their systems, made sure they worked, made sure you were getting the proper airflow where you needed it. But if you didn't have MEP on your project, you may not have had anybody else who knew. And, my experience as a rater, and even I think Allison posted in the chat, like HERS isn't the only game in town. Obviously, there's lots of different certification programs, people who are doing verification, whatever. But even on top of that, with all the stuff that we were doing is we would have people who would come and they would install it and then they would test it only at the system. So we didn't know, like, it was balanced. Yes, we were getting the same in and the same out, but we had no idea where it was going once it was in our building. And for me, that was always a challenge because, I can't guarantee it's working correctly or doing the things that it's supposed to do, or, pulling the CFM from the areas where we need to exhaust pollutants and stuff. And so, that was where I just started looking for other things. Okay, like, what do I even need to look for? What do I need to be paying attention to? And so I do use it in my own personal projects. I don't have a lot of time to do other projects, so I don't do kind of independent HERS inspections anymore. I call Mike and say, hey, come to Maine. Somebody needs something tested. Or actually one of our other raters, Bill, does a lot of my field inspections because, there's not enough hours in the day.
We had a good audience question, I think, or a lot of good audience questions, but one jumped out for me from David Gerstel, who's the author of one of my favorite books, Running a Successful Construction Company, which got me into and out of a lot of trouble in my younger contracting days. His question is, let's see, let me paraphrase it, or let's say what are the top 3 tasks that a builder needs to focus on versus getting into the details, as we all like to nerd out on. What are the big 3 things that a builder should be verifying? And this is independent of programs, or like not considering going through a program, just from a practical, what is the most important things to do? Kramer, what do you think are the 3 most important things to verify on a project?
God.
Or pick one.
Everything.
Is it envelope? Is it mechanical? Or is there more specifics within that?
Yeah. Yes. All of it. What the thermal enclosure is, how it works, what it does. At the very least, know the Joe Stiebrick 4 control layers. Understand what those are and why. And then just like airflow in and through a building in terms of like air leakage and blower door, ventilation and how that's different from infiltration, and building pressurization, ERVs, what they can and can't do, range hoods and fireplaces, how they can interact, and just the importance to maintain a neutral building pressure. So that's the way I approach things like range hoods and makeup air versus ERVs. Nothing should influence anything else in that building in terms of air pressure. That's when you get into trouble. So yeah, how air moves in and out of buildings in multiple contexts, and what the thermal enclosure is and isn't. So I guess that's sort of 2 things, but it's also 19 things. So.
Right. And if I had to put it in order of 3 things, I'd start with ventilation. And often tell, when I'm making a top 10 list, I often say 1, 2, and 3 are ventilation. But
and 4th is dehumidification.
Well, so make sure you have a good ventilation system. Then reduce your loads. You know, we always want people to focus on the air tightness and the insulation, the good windows, the reduction of your heating and cooling loads, hot water loads, and then finally putting in good mechanical systems that are appropriately sized. But if you don't get those things in that order, I think you run risks. The most important thing is the air we breathe. The next most important thing is reducing the load, and finally choosing appropriate equipment. And believe it or not, I'm not talking always. You know, I love heat pumps, but I'm seeing, particularly in Maine low-income projects, plenty of projects that just use electric baseboard heat and ceiling fans for cooling, and those are passive house projects. They qualify for the passive house levels of energy use. You know, part of the reason they get away with electric baseboard heat is because the heating load, even in Maine, is so tiny. But you got to get the steps in the right order, and you have to have a good ventilation system.
Yes, shout out for Allison, who's in the audience. Hopefully he is coming to Silver Spring, Maryland, the last week in February for anybody else who hasn't decided to come yet. And he talks a lot in his presentation about oversizing mechanical systems, right? That's a big problem. Oversizing
It's so disappointing to me because we're in the middle of a massive electrification effort. And over and over and over again, I see systems that are 2-3 times as expensive as they had to be because people designing the system weren't aware of how good a job the builder was doing with the envelope. And over and over and over again, we see systems which are too big, have too much distribution. And I just know that we could do so much more with less if we got these systems right sized. They can be tiny in a well-built home, just meeting code.
Yeah, I am honestly quite worried about all this new money for heat pumps that we're starting to see flowing. I mean, on the one hand, it's great, but on the other hand, we're going to be seeing people slamming in these heat pump systems left and right that are oversized. They're not going to work well. And it's going to be the same thing that happened when I sound like a cranky old man here, but it's whatever's happening. CFLs, they sucked at first and wrecked their reputation. Low flow toilets, the same thing. The heat pumps, there's going to be a backlash because of all these oversized and poorly installed systems. And I don't know what to do about it, but I'm seeing way too many contractors grossly misrepresent their capabilities. Oh yeah, they modulate down to 1%. No, they don't. Some of them are best at 50%. I mean, I've worked with some great contractors, but I would say the general public, what I'm seeing out there, and you go on anywhere, GBA, you find home building forums, hell, even Reddit, all these horror stories of these oversized systems installed poorly. They're not working well. They're not efficient. They're noisy. They're not dehumidifying properly. It's bad, and we need to get a handle on this if heat pumps and electrification in general are actually going to work out for us. Because it's honestly quite scary, some of the stuff I've seen out there being installed.
Yeah. And Lou Harriman, hi Lou, was asking about the size of some of the heat loads we see. Across Massachusetts and Maine, we often see multifamily heat loads that are on the order of 4,000 BTUH. So, the tiniest of single split heads are now at 4,000. But we're talking about the whole home. We don't want one in each bedroom necessarily. You can really, we're always trying to bring the size down. When you talk about modulation, we love these single split systems instead of multi-split systems because they modulate to lower loads. We love the new NEEP database. And if people aren't familiar with this, the Northeast Energy Efficiency Partnership, which is one of these regional energy organizations, there's 6 of them across the country, has come out with a database full of wonderful cold climate heat pump data. So if you just Google air source heat pump and NEEP and EEP, you'll come to this most amazing directory giving cold climate performance of a long list of thousands of different combinations of heat pumps now. So when you do that, you can also put in your location and your anticipated heating load and get that from your HERS rating, not from your manual J software. If you want to be a little more accurate, usually when we review manual J software, usually there are major problems with the inputs.
Oh yeah.
So it's hard to get a manual J to accurately describe really high performance homes.
Yeah, even manual J, which I have plenty of gripes with, oversizes at least probably 10-15% on a properly done one. And then if you're talking high performance building like passive house where you can actually take credit for solar and internals, it'll be 30 or 40% oversized. Unfortunately, it's the most widely recognized tool out there and specifically mentioned in a lot of codes, but it needs to be updated. And coming into this stuff out of passive house where like PHP and Woofy passive are like using a scalpel, you switching back to manual J feels like I'm being blindfolded and handed a baseball bat. And like, here you go, figure out the heating and cooling loads for this building. They'll be close enough.
Yeah, absolutely. But so that NEAP database, I really hope everybody goes and checks it out. I saw somebody posted the link in the chat.
I dropped it in there.
Great. You use the there's an option to use the sizing in there, and it will show you all the different bin data for the heating season, how many hours you are at different temperatures outdoors, and what the capacity of the equipment is, the range of capacities, all those down to 5 degrees and often even colder. And what it's going to show you is what percentage it'll actually calculate for you the hours of the year that are unmet by a particular selection of equipment, and the hours of the year and percentage of those hours of the total year where the equipment is low load modulating, meaning it's at its absolute minimum and just turning on and off at the absolute minimum. We see plenty of systems that never get into the modulating range. They're always low load switching and just turning on and off. So that is a brilliant way to help sort this out for people. It's brand new in the last year or so. So hope everyone takes a look at that. What did Allison say? You wanted to clarify something? It must have been funny.
Oh, just I was relaying Allison. I've heard him describe one approach is yes. Kramer's modeling it.
I have 4 tons.
Stand at the street. How many fingers does it take to cover the house?
Right.
That's your tonnage.
Yeah, that's actually not even a joke. That's real. Like there was a study I think someone in Florida did about how contractors size systems, and that was like actually one of the answers.
Yeah.
All right.
Oh my gosh.
Let's see what else we have for audience questions here. Or actually, one I had a follow-up. Michael mentioned that items 1, 2, and 3 in importance were ventilation systems. Or in terms of checking, what do you verify? What are the most important? And I'm sure that's partly in jest, but as somebody, I'm very interested in all this, but I'm not a HERS rater. I don't do verification, and I haven't been involved in the end stage of a lot of things. So I'm actually here to learn as much as anything. What do you measure when it comes to ventilation systems? What are common problems?
Sure. So all HERS raters now are measuring the exhaust and supply air of ventilation systems meant to meet ASHRAE 62.2 outdoor air requirements. For a long time, we were just doing bathroom exhaust fans to meet these requirements, and those worked pretty well. I liked them because they were relatively simple. And when we saw ERVs and HRVs installed, they are just an order of magnitude more complicated. And of course, that meant we had an order of magnitude more problems to figure out. The controls are important. The balancing is important. When it comes to controls, you want a system. Well, there's only a handful of systems that really. There's one. There's only one system I really like for everything about it. And it's the Panasonic IntelliBalance. I think Lou has one in his attic. I think it might be the first place I saw it. But the brilliant thing about the Panasonic IntelliBalance is that you don't need to have your own special flow hood to measure the airflows. It's got static pressure adjusted dials for both the supply and the exhaust air. So you can set it to the flow rate you want, and the fan's going to change its power output until it gets that flow. So that's brilliant. Most other ERVs have either one speed or a handful of speeds you can switch between, or maybe it has a continuous adjustment, but you don't know what you're adjusting to unless you also have a flow hood on the thing. And it's hard to put a flow hood on them. If you're talking about the outside of the building, which is a nice convenient place to measure the total flow, where it comes from the outside, where it goes to the outside, it's very often hard to get to that location. It might be on the roof, it might be high on a wall, it might be kind of sketchy to try to get to that measured. And certainly while you're adjusting the flow rate at the controller. We think more important perhaps though is the air that gets to particular locations on the inside. So perhaps it's better just to measure at each individual register, which is what we default to.
Yeah, to your point there, Michael, like there's also the the new Zender Q systems all measure and self-balance. And I have a job right now where the Zender was reporting is doing a certain amount of airflow, but when our rater went around to measure all the airflows, they found one that the bathroom was coming up short. Yeah. And that the total of what they measured in the flow hood was like 100 CFM short of what the Zender was reporting that it was moving.
Yes.
So we're like, what's going on here? So we stripped the cover off, set up the duct blast this stupid thing, and it's losing, 130 CFM 25 and 230 CFM 50. Its design flow rate is like 180 CFM. So even if these super fancy self-balancing digital control systems tell you they're working fine, you need to still verify that air is getting to all those rooms, all the supply to those rooms, and returned back from those bathrooms, and not being lost in leakage in the duct system. This was kind of like a hybrid sheet metal plus the Zender flex duct system. So there were leaks in, guess what? The sheet metal flex that after they opened up the ceiling, the house is done, sheetrocked, owner's moving in any day now. We go to balance the system. Hey, wait a minute, what's going on here? We got to start cutting into ceilings, finding these leaks.
Right. So I do a lot of multifamily now. I do a lot of multifamily passive house verification. 50 unit, 4-story, 5-story, 6-story buildings. Big central ERVs in the roof. Swagon is one that gets used. There are others, Greenheck. But the Energy Star multifamily new construction program, which is relatively new, starts to look at all these central systems. Well, Energy started first with the single family homes and gradually moved into multifamily. And now they have a dedicated multifamily program, which I think is going to be super popular because of the big 45L tax credits. But there's a really enlightening requirement in there. This is Energy Star. They say that we're going to ask you to measure your ventilation duct system now for that. And you shouldn't lose more than 30% of your design flow. And does that sound crazy to you that you are allowed to lose 30% of your design flow? That means your system is 30% bigger than it needs to be. That means you're that much extra heating and cooling load. That means that much extra electrical power needed. The fact that they chose that target, though, tells me that that's better than the average that they evaluated when they decided on that limit. And that's been my experience too. The last building where I did this had 48% leakage. I talked to an engineer who says, oh yeah, I always design my systems to have 100% leakage. In other words, they lost as much as they delivered to the registers. Don't know where it's going. So that, talk about wasteful, right? We oversize our heat pumps, but we also are oversizing a lot of ventilation systems, and on purpose, because we don't have no faith that the duct system is going to be tight enough. So what do? Test the duct system. Make sure it's tight enough before the balancer does their work. Otherwise, you're setting the balancer up for failure.
Carl Seville, who also does this kind of rating verification stuff, said Energy Star multifamily is a simple program except for the 150 footnotes that are almost impossible to manage. Would you guys agree with that? Are you familiar with that?
You got to have some good readers.
Oh, geez.
Yeah. Well, even the single family, there's
Yeah.
like it's a 2-page. What's the design report that I have to fill out is 2 pages long, and some of it's just like header information, and there's 2 pages of footnotes.
Yeah, and those are the negotiations and love songs that let you have a standard, right? They're actually responding to all the comments and interests of everybody trying to participate. And
Some of it's been very useful, like
Yeah.
the super low load stuff. Anything under 2 tons, you can oversize or whatever. Like that saved me on a few projects because we couldn't zone properly and meet load capacities the way the program wants you to.
But you know what? It's complicated. Yes, we have a checklist. Yes, we have footnotes, which in fine print are as longer than the checklist. And then even further, if you want to really dive in, there's a policy record that's hundreds of pages long and explains the comments they've gotten and the feedback they've gotten. And sometimes you have to go to the policy record to even figure out what you're doing. So this is a whole full-time job. You need to do this all the time to stay up on all this.
Yeah. Buildings are complicated. So
So when we say there's 150 footnotes, and that shouldn't be it's what it has to be, to accommodate all the different things we're trying to do in buildings. And it's a full-time job to keep up with it, and I love the job. But I get frustrated by architects like the one I had to talk to first thing this morning, who's been doing this forever, and he knows all this and doesn't need a checklist, right? And I asked him, okay, you're brilliant, but do you think checklists should exist? I mean, is everyone as brilliant as you? And I was actually able to bring him around to acknowledging that, okay, the checklists have a purpose.
Feed the ego.
And you mentioned ventilation, and Allison mentioned something in the chat box about dehumidification. And as far as I know, Zender is the only one that has an inline dehumidifier as part of or just started to partner with Santa Fe with putting dehumidification in as part of the ERV. Should they be separate units? I always wonder if you're asking your system to do too many things. People always ask me like, oh, can I just run my ERV or my ventilation through my mechanical system ductwork? Well, it's not the same size. I don't know. It depends. That's my favorite sentence. It depends. And, should dehumidification be standalone and be its own thing? I don't know.
Yes.
The simple answer
100%.
is yes.
Yeah.
But it's not the only answer.
The really hard answer is no. I can combine it because I'm brilliant. You probably aren't brilliant enough to combine it. It's probably not going to work the way you want it to all the time. When you combine it, you're setting yourself up for a really complicated slew of scenarios. Remember, you got modulating systems for your heat pumps now, for your air handlers. Those are changing their pressure on the system all the time. Meanwhile, you got a ventilation system that might have 1 or 2 speeds that's trying to move air through the same ductwork. Is that going to be constant? No, it's not going to be constant. It's going to change as your modulating system changes. And are you going to design it for the heating to be on or off? How are you going to set the system up? It's really fraught with problems when you try to put that ventilation air down the heating and cooling ductwork.
I just wanted to bring it up. I didn't say I was going to do it, but I like to hear things on screen to debunk.
Yeah, I mean,
No, absolutely.
all of these things happen at the commercial scale on a regular basis, and the controls and equipment are all built to be able to do that. At the residential scale, where we're talking about cooling systems that are 1 to 3 tons, dehumidifiers 50, 60, 100 pints a day, it's also like it's literally a communication language thing. We're getting our fancy ERVs from the Netherlands. mini split heat pumps from Japan and Korea, and our dehumidifiers from the US. They don't even speak the same control language. So just tying them together can sometimes be difficult. It's possible, and I'm doing it on some jobs now to eliminate some ductwork, but best is let your ventilation system ventilate, let your heating cooling system heat and cool, let your dehumidifier dehumidify, independently ducted, independently controlled, because these are all different things that we're dealing with, but we're working towards integrated systems, but we're not really there yet to roll it out on like a every single building kind of basis.
Totally agree.
So just to change gears a little bit, because, or at least in the Pretty Good House book, we combined verification and client education because they are closely related. David Gerstel points out that if you have a homeowner's manual that's supposed to explain how to operate this, what's becoming more and more complicated system called a house, one in 100 will read it, 1 in 1,000 will understand it. Are we making homes too complicated, or what can we do, or should we be doing about these systems? Should we just go back to making houses leaky and let them breathe and blah blah blah? Michael's head just exploded, but it's.
I think we did a BS and Beer show on that once about historic preservation versus building science. Didn't go well.
So
I don't think.
Yeah. Yep.
Yeah, I'm not touching that with a 10-foot pole.
Okay. We'll leave that alone. Coda has a good quote from Joe Stiebrick. Engineers suffer from the integration gene and want to combine everything. Don't.
Thanks, Coda.
Yeah. And an engineer I'm working with, my friend.
He's not wrong.
Or my friend Bob Morrison is an engineer I'm working with on a project, and mentions dehumidification and ventilation should be separate. Ventilation and flow rate is incompatible with dehumidification flow rates. We're doing a project where we're sort of being forced to combine dehumidification with a central heat pump system. So we're combining dehumidification with the heating and cooling, which isn't ideal, but we have a lot of different systems already. Kramer's looked at it and understands the system. Is that a good approach, bad approach, okay approach if you're kind of backed into a corner? What do you think about that? Or about combining dehumidification with the heating and cooling ductwork?
In theory, it should work fine, and I think in practice, they've kind of got that figured out down in the South.
Okay.
Like you often see dedicated dehumidifiers tacked on to a central air handling system. And you may, hopefully your central air handler fan power use is not obscene. It probably is. I wish I had better controls even with my nice efficient mini splits when I'm doing that integration. And there's an article by Andy Ask about this, and then some good stuff on GBA from David Trelevin about integrating, what side, return side, supply side, whatever, or independent. It's been looked at, but I don't think we're doing enough of it, especially in our climates up here in the north, which are becoming more and more humid. Like the last 3 summers, I've had nothing but dehumidification problems on jobs. I think every new house up here needs a dehumidifier. Just like we're getting dew points in the low 70s for weeks at a time. It's disgusting. Mm-hmm. And the mini splits aren't handling all of it because the low load house, maybe you even have shading on it, probably not, but we can handle the sensible cooling loads fairly well now. But the latent loads, especially with ventilation requirements, we're not handling those, and that's going to be a big problem in the coming years. So, you guys up in Maine, I know Emily, I was just watching your fine home building videos. That first module is phenomenal. I love seeing the dehumidification stuff mentioned. That you guys up in Maine are even now, using ACs and dehumidifiers. Like that's coming. We're all in a mixed climate now, guys. Like, get ready for it.
Good. I need all your feedback. The next level. You gotta do the next level deep dive.
Well, let's see how some of these integrated systems actually work out. That, verify it. Go back and freaking measure the results. Does it actually work the way the theory says?
Oh.
Yeah. Well, or we are coming up on the hour, and which is kind of a new change. We're used to 90 minutes and getting used to this being a relatively compressed conversation. What have we not covered that you guys think are important when it comes to what do novices and the pros? We have a lot of highfalutin folks on this call from all over the country, names we all know, and a lot of beginners as well. What do people really need to know about verification? What should we all be doing? Builders, architects, homeowners.
Recognize that people doing verification love the work. They're doing it for a love of buildings, a love of doing things better, and it's we're not narcs. We're not there to rat people out and get people in trouble. We're trying to help, and we do help. We're not there just to check a box in a checklist and say we're done. We are there because half the time, if not more, things are not done as well as they could be, and as well as the stated goals of the project. And when that's the case, we're troubleshooting. We're troubleshooting all the time alongside our clients. So I think too often when I think about money, which thankfully is not too often, I think, hey, I'm only charging for like what it would cost to run in here and say it was all done right. maybe I should charge more. But then, I think there's a perception here from a lot of people that that's all we do, and that's what I want people to know. That's not all we do. We don't just run in and say, "Good, bad, I'm out of here." Call me when you fixed it. Where we take time, and when there's a failure to meet a requirement, we take an order of magnitude more time to try to help our clients figure it out. And we're there as a resource from the design phase through mid-construction to occupancy to help troubleshoot all these problems and provide feedback based upon the wide range of work we get to see. We're always pollinating ideas, cross-pollinating ideas from one job to the next. We get to see all the best and all the worst, and we're going to try to share what we've learned.
Excellent. Kramer, final thoughts?
I would just say, like the cost of verifying, whatever that is, getting someone to balance your ERV, commission your heat pumps, or to throw in a couple of, Wi-Fi enabled indoor air quality monitors and maybe, a power monitor, like a Sense or an Emporia or something on the electrical panel. That's like a couple of $100 worth for some of that equipment. Maybe I don't know, $1,000 or $2 sometimes for a larger house, measuring systems. But that is cheap compared to what you can learn from it and problems it will prevent down the road. And just being able to, go into that next job and saying, this worked last time, we caught some of the bugs, whether they were in design or implementation, we figured it out. We're going to catch those earlier now on all these next ones. You have to be closing the loop on this design cycle. If you're just putting plans out and saying, here you go, have fun, you're only doing half the job.
Yep. And as a verifier, I love the ongoing relationships with builders, developers, and architects, and even engineers, as we try to do better.
Some of us are okay.
Yeah. Or sorry, yeah, just one follow-up question. Whose responsibility is it to engage somebody to verify? Is it on the homeowner? Is it on the designer or architect? Is it something the state imposes on you?
The builder is, I think, in the best position to work with a verifier.
Okay.
I think that's the most valuable long-term relationship.
Okay,
because
so they should include it in their proposal, contract, whatever. They should include
I think so.
a line item for verification.
And they should get to know. They should get to know their verifier, and they're going to learn together and improve from job to job.
Mm-hmm. Excellent. Well, we happen to be right at 7:00. Nice. Or just like we planned.
That was perfect. And I think a pretty good house tenet is definitely build your team, right? We're all more successful together. Right. So a contractor said to me, there's never enough money to do it right the first time, but there's always enough money to fix it. Like that's a thing I think in building we should just get rid of. Right. That would be nice. That would be good for everybody. Building more durable buildings. I think that's what we're all here for, the building science, right? So
Yeah.
thank you
Yeah.
both for joining us. Clearly we could have talked for, another hour or more. This is one of my favorite subjects.
I'm disappointed I couldn't follow everything in the chat. The amount of
Well,
it's great stuff there.
I'll save it, and
Yeah.
if anybody wants it, just email me. I'll send it to you, Michael. And
Yeah.
if anybody else wants it, email me, and I'll send it to you.
Someone asked about Mass Save and New Hampshire Saves and verification with, and we definitely have verification in those programs. So I think they might be talking about, they're probably talking about the existing homes program. And yeah, I'm sorry. We've been very biased towards new construction here today.
Yes.
The existing homes are the next big nut to crack, but
It's yeah. Building science always tends towards new construction because it's way easier and cleaner than dealing with renovations. I was like,
It's easier to explain.
yeah. Next time we'll do verifying renovations. That's the next challenge.
If you think I say it depends a lot about new construction, well, renovation, buckle up.
Brace yourself. All right. Thanks a lot, guys. Thanks a lot to our audience who are very engaged tonight. Really appreciate it. Appreciate your time and thoughts and sharing and all that good stuff.
Yeah. Awesome show.
Cool.
Thanks, guys.
Thanks, everyone.